Let's use what we know about graphs to find the answer to these questions. Jorge is emptying his pool. According to this graph, how many gallons were in the pool to start, and how quickly is the pool draining? So when we ask, according to this graph, how many gallons were in the pool to start, we're asking for an initial value, right? It's in the pool to start. It's when time equals 0. It's before the pool is being emptying. So the initial value is where we start at the beginning of the scenario. So notice that when x equals 0, there are 2,000 gallons in the pool. The y-intercept of this graph is 0, 2,000. So therefore, Jorge started with 2,000 gallons of water in his pool. It's the y-intercept is the answer. Now, to answer the question for how quickly the pool is draining, we need to find the rate of change or the slope of the line representing the emptying of the pool. To do that, we'll find two well-plotted points and find the rise over run. So we're using this point here, our y-intercept of 0, 2,000, and this point here of 9, 1,000. So our rise is we have to go down 1,000 units, so that will be negative 1,000, and we have to go right 9 units, so that will be a positive 9. So negative 1,000 over 9 is our rise over run, which simplifies to approximately negative 111. So this is the slope. So to answer the question, we can interpret that as emptying 1,000 gallons every 9 hours, or approximately 111 gallons per hour. Another way to find this would be to make ordered pairs, or to identify ordered pairs and use the actual slope formula if you don't want to count the rise over run. So let's say we use the 2 points of the y-intercept 0, 2,000 and the x-intercept of 18, 0. If we use our slope formula, remember that's y2 minus y1 over x2 minus x1. And we have x1 is 0 and y1 is 2,000, x2 is 18 and y2 is 0. Our slope would be 0 minus 2,000 over 18 minus 0, which equals negative 2,000 over 18, which can reduce to negative 1,000 over 9, which is approximately negative 111 per 1. So it's the same answer we got using the rise over run, it's just using the slope formula. And notice it's consistent and makes sense that our slope is negative because the pool is being emptied. The pool is losing water at a certain rate, so we would want the slope to be negative. It should be losing a certain amount of gallons of water per hour. So using the y-intercept and the rate of change, we were able to answer these questions about the situation using the graph.